If I look at the first one, what number goes into all three of those terms?
4.
4. Okay, if I take out a positive 4, then I'm not changing the sign. So this would be negative x squared plus 3x minus 4. And then we'll soon see that we're going to go a little bit further with this. But for right now, we're just factoring out the greatest common factor. If we had factored out a negative 4, then it would have been x squared minus 3x plus 4. So it would have looked like that. Number 2, what can you factor out of each of those terms?
3.
3 and? X. Good. So I take out a 3x and I'm dividing each of these terms by 3x. And I get x squared minus 2x plus 3. Questions on that one? Okay, what can I factor out of 3? This time it's an expression, right? I have x minus 2 on both of these. So I can actually take out x minus 2. And what's left is 2x and 3. Let me change that color. So sometimes your greatest common factor is an expression, not just a single term. All right, so then the last one, I have x plus 3 squared minus 4x plus 3. Again, that x plus 3 is the expression that I can take out. So x plus 3 would go to the front. Then there's an x plus 3 still left. So it would be x plus 3 minus the 4. And then I can do one more step here, x plus 3, and then I can simplify the x plus 3 minus 4 to be x minus 1. Question on those. Is the difference of two squares. So this name tells you exactly what it is. Difference, which means a minus, and then 2 squares means 2 perfect squares. So when the two terms of a binomial, this can only have 2 terms, are both perfect squares, and there's a minus between them, it's called the difference of 2 squares. And the way that we factor it is by square rooting the first term and square rooting the second term, repeating it, one with a plus and one with a minus. So if I look at this example here, x squared minus 4, x squared is a perfect square, 4 is a perfect square, there's a minus in between. So when I factor this out, I'm going to square root the first term and I get x and x. I'm going to square root the second term and I'd get 2 and 2. And one of these parentheses gets a plus and one gets a minus. And then again, we can always check these by foiling that back out. So first, x times x would be x squared. Outer, negative 2x. Inner, positive 2x. Last, negative 4. These cancel, and I get x squared minus 4. So every single factoring question can be checked. Questions on those? All right, let's see if we can work through these. How about you guys try them? I'm going to give you a couple minutes to work out these examples. All right, so if you look at the first one, you get 9x squared minus 49. These are both perfect squares. When I square root the first term, I get 3x. So that goes first. Square root the second term, I get 7. And one of these gets a plus and one of these gets a minus. And the order there doesn't really matter. It could be plus or it could be minus, or it could be minus and then plus. It doesn't matter. I would say that if this is a question on the test and that's an open-ended question, you can make the habit of always putting the plus first, but it doesn't mean that it's wrong. And then when you're also, like, keep in mind that when we're typing these kinds of questions in, you'll put no spaces there. So it would be the parentheses 3x no space plus no space 7. Okay, so you can kind of think about the format that it would be on your test. All right, number 6, 36x squared minus 49y squared. So this, again, two perfect squares, minus between them. This would be 6x and 6x, and then 7y and 7y. One gets the plus and one gets the minus. And number 7, both perfect squares, minus between them. So I would square root the first. I get 2x. Square root the last, 10. One's got a positive, one's got a negative. Now this time, keep in mind that we're going to keep going. Usually it will say something like factor completely. You could have actually taken out the 4 from the beginning and still kept it the difference of two squares. It would have been x plus 5 and x minus 5. If you didn't take the 4 out first, then you can take it out of these by taking a 2x plus 5 and then a 2x minus 5, and you still get 4x plus 5, x minus 5. So sometimes there's going to be more than one step to factoring, and I would say always start with your greatest common factor. All right, the last one says 25x squared plus 36. This is not a difference. This is a sum of two perfect squares. This can't be factored. So this is considered to be prime, okay? It can't be factored. Then we put prime. Questions on those?
Why can't you factor them when it's a sum?
Because when you distribute this last term, if you think about it, when you're multiplying that out, one's a positive, one's a negative, that's always going to give you a negative. So the factoring term is difference of two squares. It can't be plus two squares, so it can't be at the sum. All right, some more examples. So the exponents are just getting a little bit higher. The numbers are just getting a little bit bigger. So x to the 8th minus 1. These are both perfect squares. If the exponent on the variable is even, it's a perfect square. So when I square root x to the 8, it's x to the 4th and x to the 4th. Square root of 1 is 1 and 1. 1 gets a plus and 1 gets a minus. Now that first one is the sum of two perfect squares, so it stays the same, but the second one is actually a difference of two squares again. So if I factor that out, I'd get x squared plus 1 and x squared minus 1. Now that second term is the sum of a perfect square, which I can't do anything with, but the last one is this difference of two squares, so I can actually factor that one more time, x squared plus 1, x minus 1, x plus 1. Which step?
The second.
So from here, this x squared plus 1 is the sum of perfect squares. I can't go anywhere with that. But x to the 4th minus 1 is, again, the difference of two squares. So I can factor that out into x squared plus 1 and x squared minus 1. And then I've got two sums, so these two stay the way they are. But this last one is the difference of two squares again. So I can factor it further by square rooting the first term and the last term. So you want to keep going until you can't break it down any further. All right, so number 10 is 625x to the 4th minus 1. If you don't know that square root, then think 25 can go into here. It would be $6.25 would be 25 times, right? And then you can break this down more if you wanted to, or you can see that right there, there's two 25s. Two 25s means that the square root of 625 is 25. X squared, 25x squared, 1 and 1. 1 gets a plus and 1 gets a minus. 1's a sum, I can't do anything with, but the second one is the difference of two squares again. So I can keep the first one the way that it is. The second one becomes 5x plus 1 and 5x minus 1. Good morning. Sure. I was going to say, it's a mess in here, too. My stuff's all over the place because it... Oh, boy. If you need me to, I should clean off my stuff, though.
Like, I don't want to interrupt you.
Okay, I'm going to give them a couple examples and then I'll. All right, number 11, you can take a 3 out, right? So if I take a 3 out here, I'd get 3, divide each of these by 3, and I'd get 1 minus 4x squared, the 3's on the front. And then, again, difference of two squares, right? 1's a perfect square, 4x squared is a perfect square, so this becomes 3. Square root of 1 is 1, square root of 4x is 2x. 1's a plus and 1's a minus, and that's as factored as you can get it. If you didn't catch the 3, obviously you wouldn't have been able to do the difference of two squares. So always make sure you're checking for greatest common factor first. Questions on that one? All right, last one, and it is a difference of two squares, but that first one is an expression, right? So it looks not the same as the other ones. If I square root x plus 2 squared, I get x plus 2 and x plus 2. If I square root y squared, I get y and y. One gets a plus and one gets a minus. If I could simplify that, I'd keep going, but I can't, so that becomes the answer. Questions on that one? Good. All right, two squares. Again, the first one is, they're both perfect squares, the minus between them. So when I factor that out, x minus 1 squared would be x minus 1 and x minus 1. 9 y to the fourth would be 3y squared, 3y squared. And then 1 gets a plus and 1 gets a minus. These, like the second one, when you square root it, there's 9y squared is not a perfect square, so I can't go any further with that. That is how it will be left, which I know looks weird, but that's right. Number 14, again, difference of two squares. This time, if you go from here, right, I'd get 9 and 9 and 6x and 6x. 1 gets a plus and 1 gets a minus. You can take something out of both of these. So that's why I would start doing it from the beginning, right? So both of these are divisible by what? 9. So if I take 9 out, I get 9 minus 4x squared. That's still the difference of two squares. So I'd get 9 and then 3, 2x, 2x. 1 gets a plus and 1 gets a minus. That is what you want to do. Always factor it from the get-go with your greatest common factor. If you didn't, then you'd have to look at these and say, okay, I could take out a 3 here, and I'd get 3 plus 2x. I could take out a 3 from here, 3 minus 2x. And then the 3 times the 3 makes it 9. 3 plus 2x, 3 minus 2x. And then 15, again, difference of two squares. This would be x squared and x squared. And then 4y, 1 gets a plus and 1 gets a minus. Now this one is the difference of almost two squares. X squared is obviously a perfect square. 4 is a perfect square, but y is not. So it actually will stay just the way it is. Questions on those? Okay, so that's the difference of two squares. The last thing we're going to talk about on today's notes is the perfect square trinomials. So trinomial, tri means 3. This has 3 terms, okay? The way you test to see if something is a perfect square trinomial is you square root the first term and the last term and double the product of those two terms. If it matches the middle term, then you know it's a perfect square trinomial. If it doesn't, then obviously it's not. So that test would look like this. Square root x squared and you get x. Square root 25 and you get 5. Multiply those two together, I'd get 5x. Double it, and I get 10x. This is a perfect square trinomial because that middle term is 10. Ignore the plus or minus for that test. Now that's just the test of it. To actually factor it, you're going to square root the first term and the last terms and then take the sign from the middle term. So I square root the first term and I get x, square root the last term and I get 5. Take the sign from the middle, which is minus, put it in parentheses and square it, and that's my perfect square trinomial factored. It's the same thing as x minus 5 times x minus 5. Those are the same things. So the first thing is the test, and the second thing is actually how you factor it. All right, so they look like this. 16, first thing we're going to do is test it. Square root the first term, this is 4x. Square root the last term, that's 3. Multiply them, that's 12x. Double it, and that's 24x. So that means this is a perfect square trinomial. And then to factor it, we would square root the first term, which is 4x. Square root the last term, which would be 3. Take the sign from the middle, that's a plus. Put it in the parentheses and square it. Questions on that one? All right, 17. Test it out. Square root the first one. Square root the last one. That's 15x. Double it. 30x. It is a perfect square trinomial. So we square root the first term. Square root the last term. Take the sign from the middle. Put it in parentheses and square it. This test here. Well, first of all, they have to both be perfect squares. The first and the last one have to be perfect squares, right? Then you want to do the test, which is like, so if I do it for 18, I square root the first term. So the square root of 4x squared would be 2x. I square root the last term, which would be 1. Multiply that together, I get 2x. Double it, and I get 4x. If that matches your middle term, then you know it's a perfect square trinomial. Okay, and then to factor it, we square root the first term, square root the last term, take the sign from the middle, which is positive, put it in parentheses, and square it. And then again, you can always expand that and FOIL it, right? Because you can always check these answers. Just be careful, because that's a common mistake a lot of you made on the quiz, was like, if I'm going to expand 3x minus 5, it is not 9x squared plus 25. You can't distribute an exponent on a sum or difference. You would have to expand that out so it's 3x minus 5 and 3x minus 5, and then FOIL it. 9x squared, negative 15x, negative 15x, positive 25, and I get 9x squared minus 30x plus 25, which matches the question. So again, these can always be checked. Questions on that one? All right, last slides. You guys try them. All right, so the test on 19, square root the first term, and I get 6y. Square root the last term, I get 7. Multiply those together, I get 42y. Double it, and I get 84y. Matches the middle term, so I know it's a perfect square trinomial. Square root the first term, square root the last term, take the sign from the middle, put it in parentheses, and square it. Questions on that one? All right, 20, square root the first term, I'd get 3u. Square root the last term, I get 4v. Multiply those together, I get 12uv. Double it, and I get 24uv. That does not match my middle term. My middle term is missing the v. So this is prime. So be really careful. That middle term would have to have the u and the v on it. If it did, if, for example, it said 9u squared plus 24uv plus 16v squared. Then when I factored it, it'd be 3u 4v, the plus from the middle in parentheses squared. So it would look like that. But it would have had to have the v on it, which it did not. So this original question was prime. All right, questions on anything we talked about today. So we talked about 3 different kinds of factoring: greatest common factor, difference of 2 squares, and perfect squared trinomial. Those are 3 of the many that you're going to eventually learn, but that's the first 3 that we're going to talk about. And remember, you always want to check for the greatest common factor first. Everybody's good? Yes. Okay, I'm going to publish your homework so that you can go on and grab it. We've got about 20 minutes, and I want you to do 2 things. 1 is get a head start on the homework. 2, let's go to the quiz. Hang on. Okay, so this is what your homework looks like. Again, I want you to get a head start on it in just a minute. First, I want to talk about the quiz. This, and it's 2 pages, is the different kinds of factoring we talked about today. All right, there, it's 2 pages. And I also want to remind you that the answers for the odds are on the Calc Chat link, which is on the home page. So if you go into the Canvas course, wait for it to load. On the bottom of that home page, there's a link to Calc Chat. So if you click on that link, spinning. There we go. Okay, when you click on that Calc Chat link, it should take you directly to your book's answers. So we're on chapter P, but we're on section 4 now. If I wanted to check the answer for number 7, I would just click onto exercise 7 and I click go, and it's going to give you your answer. So obviously, I want you to do these. I don't want you to just go get your answers. That defeats the whole purpose of having a practice of the math. But what you want to do is be checking your odd answers so that you can make sure you know what you're doing is correct, okay? That's one thing. And then the other is you should now see the feedback for your quiz. So if you click on a couple, you can get to it a couple of different ways. But if you just went to the module and you went to the quiz, or you go to recent feedback and you go to the quiz, both ways will get you there. Okay, you should be able to see your feedback now, meaning the right and wrong answers. So there were different questions depending on which version you had. But what I want you to do is, we literally have 15 minutes. If you did great on your quiz and you have no questions, then fantastic, start your homework. But if you didn't do great on the quiz, I want you to go in there now. I want you to look at the feedback and then let me know if you need me to go over the questions. I will tell you that some of the most missed questions, actually here I can undo that way. The most common open-ended missed question mistake was what I talked about before, which was this. If you had 5x It's still locked? To see feedback or to take it?
To see it, anything. It just won't let you look at it.
When you go to your home screen, do you see the thing that says recent feedback?
I went through grades and I was able to click on the grade and hit submission and results, and it showed me the answer.
Okay, so that's one way you can get to it. You can either go directly to your grades and then click on the link there, or you can go to you should have a thing on the right-hand side that says recent feedback, and you should see it there. It's not going to let you take the quiz again. That's why it's kind of looks like it's locked, but it will let you view your feedback. So this one and the other one that was like this, a lot of you distributed the squared in. And remember, you can't do that. You have to expand this and FOIL it. So when I multiply these two, I'd get 25x to the 12th. Multiply these two plus 30x to the 6th, y to the 7th, plus 30x to the 6th, y to the 7th, plus 36y to the 14th. And then these two can be combined, 25x to the 12th plus 60x to the 6th, y plus 36y to the 14th. So that should have been the whole answer. And again, like, there was obviously another version question, but it was the same process. A lot of you left off your middle term and just squared the two terms. Let me see what else was missed. A lot, which was... Those are okay. Yeah, this one. So they're rationalizing 3 minus square root 2 over 3 plus square root 2. So you had to multiply by the opposite, which would have been 3 minus square root 2. And then in the numerator, you would have to FOIL that out. So 3 times 3 is 9. 3 times negative root 2 is negative 3 root 2. 3 times negative root 2 again, negative 3 root 2. And then negative root 2 times root 2 is plus 2. So the numerator would have been 9 plus 2, which is 11 minus 6 root 2. And then the denominator, if you FOIL this out, you could use the shortcut, which is square the first term, square the last term, put a minus between them, 9 minus 2, which is 7. That was the correct answer. So that one was missed a lot. And the same process for the other quiz, obviously they're just different numbers, but it was the same process. You had to multiply both by the denominator, by the opposite of the denominator. And then everything else was not awful. Like those were the most commonly missed questions, I think. Yeah, this is the same process. So this question was the same. It was on the other version, but 3 root 2 minus 3 is what you'd be multiplying both the top and the bottom by. So in the numerator, when you FOIL this out, this would have been 18 root 2 minus 18 minus 6 root 6 plus 6 root 3. And that couldn't have been simplified, so it should have been that big long thing for the numerator. And then the denominator, square the first, square the last, put a minus between them, and you should have gotten 9 times 2, which is 18, minus 9, which is 9. And then all of these terms were divisible by 3. So some of you just divided some of it. You should have gotten 6 root 2 minus 6 minus 2 root 6 plus 2 root 3 all over 3. I think that was it. Those were the most missed ones. So again, if you need help, please feel free to reach out. If you need me to work one of those out now, I can do that now. We've got about 9 minutes. If not, then I want you to take these next 9 minutes to get started on your homework, okay? You click on the week 3 schedule for this week is there, okay? Obviously, today we did the P4 factoring part 1, and that homework is obviously due tomorrow. And then tomorrow's... we're going to do the warm-up for P4 part 1. We're going to do the notes for part 2. And then that homework, which I also have to change the date on, should be tomorrow, which would be 9/1 for part B. And then we'll kind of follow through that format, and then we'll review on Friday, and your test again would be Tuesday of next week.